Bismillahirrahmanirrahim. Okay, now we are going to discuss topic 1.4.2, dual mode and multi-mode operation. Okay. Its operating system and its user shared resources like hardware and software. So we need to protect operating system and other system component from illegal attempt made by malicious program. Okay. So we, at least in computer system, it needs to provide with dual mode, okay, where it consists of user mode and kernel mode. Okay. We accomplish dual mode, a bit will added to hardware. Okay. So this bit, known as mode bit, okay, able to distinguish when system is running user code. So when system is running user code, the mode bit is 1. When system is running kernel code, the mode bit is 0. Okay, okay, we look at this figure. Okay, when we start our computer, okay, remember that the first program will be loaded is bootstrap program. So during that time, kernel mode, since computer system is running kernel code, okay, so the mode is known as kernel, when computer system is running kernel code, okay, the bit assigned is kernel mode, okay. Sorry, the bit assigned is 0, okay, to indicate that now the computer system is in kernel mode, okay. Okay, after bootstrap program, then it will loaded kernel into memory, okay, and then it will ready with the system software, okay. And then it will wait for the user to performing any task, okay. So when a user start the user application, okay, or user process here, okay, in the middle of user process, okay, it's may make a system call. System call means that the process needs operating system services, okay. So from this user process where the user mode is set as 1, okay, remember that when user process trigger system call, okay, means that it's give a software interrupt, okay, known as trap here. So trap will change mode bit from 1 to 0. Okay, so when the mode bit is changed to 0, okay, the computer system alert that now they are in kernel mode, okay. So when it's in kernel mode, okay, it's allowed to execute the privilege instruction. Okay, privilege instruction means the instruction that's only allowed to be executed in kernel mode, okay. So after operating system finish to execute the services needed by the user process, okay, it will change the mode bit from 0 to 1. Okay, this indicate that now the control, the control that is belong to operating system is passed back to the user process. Okay, so when the mode bits is changed from 0 to 1, okay, computer system alert that now they are execute user code, okay, so they will not allow to execute the privilege instructions, okay. That is the transition from user to kernel mode and vice versa. Okay. Remember that the privilege instruction only allow to execute in kernel mode. Okay, so another example of privilege instruction, we have input output control, timer management, interrupt management. All the instruction is privileged, meaning that only allowed to execute in kernel mode. Okay, that is how if a user process try to execute the privilege instruction in user code, okay, operating system will catch it as a trap, so the operation will be halt. Okay. Okay. Increasingly, CPU, the contemporary OS, okay, can support multi-mode operations. Okay, for example, in, visualizations, okay, have three mode here, okay, which apart from kernel mode and user mode, now it has virtual machine manager mode. Okay, so this mode is less privileged than kernel mode, but more privileged than user mode. Okay, so that's all for this topic. Thank you for watching.